So here in this case, calculate the value of load resistance for maximum power transfer. Again, in what value we are interested? We are interested in the calculation of the two parameters, that is VOC and ISC. Is it right? Because whenever we have the dependent source, maybe the current source or maybe the voltage source, in that case, we have to find out VOC and ISC because we want to find out the Thevenin's equivalent network. First, I will remove the load resistance and I will redraw the same circuit, which is the calculation of the VOC, that is for the calculation of the VTH. I will write first, removing the load resistance and redrawing the same circuit, we get removing load resistance and redrawing same circuit, we get. How will be the circuit? I will draw here. In this case, the circuit will be something like this. Circuit will be something like this. This is A point. And this will be the point B. It is 5 ohm. This is 3 ohm. It will be upward direction. It is 2Vx. This is 4 ohm. This is plus and minus. This value is the Vx and it is the 8 volt. Now look at. This value is the Vx when load resistance is present. Otherwise, I will give some different name. I will give its name as a Vx1. That's why here it will be the Vx1. Are you getting me? Now tell me, anyone, how to find out this voltage? I'm coming back to you. Because in this case, this looks to be very simple. But the things are not that much simple. I will come back to you. Yes. I will start from Tanveer. Tanveer, have you any clue regarding how to find out its value of the VOC? Yes or no first? If yes, I will proceed further. Otherwise, I will go to the next student. No. Shailesh.
Yes, sir.
Are you able to find out its value of VOC? Yeah. Tanveer. Okay, fine. Sheikh Naushad.
Yes, sir.
Are you able to calculate its value of the VOC?
No.
No. Then Saurabh.
Yes, sir.
How to calculate that value?
Using mesh analysis.
Mesh analysis. Look at here. We cannot use the mesh analysis. Because in this case, if we are assuming this as a loop, here is a current source. And whenever there is a current source, we don't know the voltage across current source. What is this value? 2Vx1 ampere. It is a current. That's why we cannot use the mesh analysis. हम mesh analysis यहाँ पे use नहीं कर सकते. Ruchira, have you any clue?
No, sir, no.
No. Rishikesh?
No, sir.
No. Here, I will discuss first and I will come back to you again. This is little typical problem. Look at carefully. हम यहाँ पे mesh analysis use नहीं कर सकते. Because we are interested in the calculation of this potential, means we have to travel from the B towards A. Again, we cannot use this path because we don't know the voltage across the current source. Means we have to follow this path. And if I am following this path, we are interested in the calculation of current in this branch. Is it right? But here, how to calculate that current? हम mesh analysis use नहीं कर सकते. Means second alternative is the nodal analysis. But again, in case of the nodal analysis, this is one branch, this is the second branch. We have only one loop. How to use the nodal analysis? There is one dummy rule, or there is one modified method. What we will do? We will assume this as a complete branch with zero current. This as a complete branch with zero current. That's why I will give some names. Now look at, while assuming the current to this branch, what I will do? I will mark this as one node, this is as another node, this is the ground node. We are treating this branch as a dummy branch having zero current. Is it right? I will name this node as a P node and its potential will be the VP because again यहाँ पे Vx नाम है, A है, B है. This VA, VB, Vx हम नहीं दे सकते. That's why I have taken its value as a VP. Now assume the current for this branch. Already current is given for this branch, which is 2 Vx1 amperes, and in this case this current will be 0. Again I'm trying to use a nodal analysis. That's why we have to assume the separate current for separate branches. For this branch I will assume its current as I1. Now how to assume the current for this branch? Look at, whenever the polarities are given to you, be careful while assuming the direction of the current. Assume the direction of the current which suits to the given polarity. Given polarity is positive, negative here. In that case, the current is a forward. In that case, it will satisfy this polarity. Which in this case, we have to assume the current may be upward. Something like this, forward. It is something like this, forward. That's why I will name this current as I2, which is forward. And this current, I will name it as I3. Is it right? I will assume this as a dummy branch because we don't have any other alternative. We cannot apply the KVL. हम KVL apply नहीं कर सकते, but we can apply the KCL by assuming this as a dummy branch. Is it right? Now look at how I will do. Applying KCL at node P. At node P. How is the KCL? Incoming current is equal to outgoing current. This is incoming, this is incoming, this is outgoing. Its equation will be I1 plus I2, which is equal to I3 is the equation. Right? Now how is the value of I1? I1 is this current. Whenever there is a current source, independent of the resistance connected in series with that, its current will be same as the value of the current source. This I1 is 2 Vx1. This is 2 Vx1 is the value of the current I1 plus I2. How much is the I2? I2 is the current in this branch. How is the formula? It is the potential 0, negative to positive plus 8 minus Vp is 8 minus Vp divided by resistance of this complete path, which is nothing but the 4. Is it right? Which is equal to I3. I3 is the current in this complete branch, which is open circuit. That is nothing but the 0. Is it right? Now we are in a position to find out this value. I will simplify this equation. It is 2 into Vx1 plus 8 divided by 4 minus it is Vp divided by 4, which is equal to 0. That is the equation. I will put the equation in terms of Vx, Vp and constant. Means this value will be 2 into Vx1 minus this 1 by 4 into Vp is nothing but 0.25 Vp. This is 0.25 Vp, which is equal to 8 divided by 4. That is 2. And this is the equation number 1. Is it right? I will come back to you. I will start with someone who was a regular in the previous lectures. Chaya.
Yes, sir.
सही है क्या ये? Calculations are correct?
Yes, sir.
Yes. Then I will come back to another student, maybe Rishikesh.
Yes, sir. Correct, sir.
Correct. Okay, fine. Now I will proceed further. This is the equation number 1. Now look at, we have the one equation and the two unknowns. Unknowns are Vx1 and Vp. Now we will find out the relation between Vx1 and Vp. Is it right? That's why I will calculate Vp. Now we need Vx1.
Sir, O minus 2 होगा ना?
Which one?
Equation 1.
Yeah. बिल्कुल सही. This is minus 2. Right. Absolutely fine. Now we need to find out Vp in terms of Vx1 or Vx1 in terms of Vp. I will find out the Vp in terms of Vx1. क्योंकि हमें ये दोनों में रिलेशन चाहिए. रिलेशन कैसा मिलेगा? यहाँ पे Vp फाइंड आउट करना है. ये पाथ यूज नहीं कर सकते, ये पाथ यूज नहीं कर सकते. Means we have to use this path. Is it right? How will be the Vp? If we are traveling in this direction, how we will find out the potential? If we are traveling in this direction, negative to positive, that is a plus, which is 8. Then positive to negative, which is minus. I will not take this value as 4 into I2. because I'm interested in the finding the relation between Vx1. That's why I will take this value as a here negative to positive plus 8, positive to negative minus this Vx1, minus this Vx1. Now we have got the relation between these two. If I will simplify this equation, how I am putting the equation Vx Vp. This I will shift this Vx on the left hand side. In that case, it will become positive. This it is Vx1 plus Vp, which is equal to 8. This is the equation number 2. Is it right? Yes or no? Anyone? Vx1 plus Vp, which is equal to 8. Now we have the two equations and the two unknowns. Find out the value of the Vp and find out the value of the Vx1 first. I'm expecting the answers from your side. Now find out the Vp and Vx1. And by knowing these values, we are interested in the calculation of I2 only. सिर्फ हमें I2 चाहिए क्योंकि हमें ये potential find out करना है. Is it right? We are interested in the I2. Then we will use this formula, that is 8 minus Vp divided by 4 for that calculation of the current. Yes. Anyone? Use the calculators. या किसके पास आंसर्स है तो मुझे बोलना. I will stop. Unknowns are 2. How is the A1? A1 is the 2. Then it is minus 0.25. The next constant is a minus 2. Next, this value Vx1 is 1, Vp is 1, and constant is 8. Sorry. Whether I did the correct calculation, just I will check once again. A1 is the 2. This is minus 0.25. This is minus 2. Yeah. Then in this case, C1 is minus 2. Fine. Then A2 is 1. V2 is also 1. The constant is 8. Yes, fine. Then X. What is the X? X is nothing but this first value, Vx1. Here, Vx1 is 0 old. Then next, Y is Vp. The second value is Vp. Vx1 and Vp. And Miss Y will be 8. Is this will be the 8 old. कभी कभी आंसर 0 आता है, इसका मतलब हम गलत कैलकुलेशन कर रहे हैं. ऐसा नहीं होता है. Because sometimes that potential may be 0. In this case, this Vx1 is 0 and Vp is 8. Now, if we know the value of the Vp, in this particular case, we are interested in the calculation of the current I2. Now look at here. How is the I2? This I2 is equal to 8 minus Vp divided by 4. 8 minus Vp divided by 4, which is equal to 8 minus Vp is 8 divided by 4. This is equal to 0 amperes. Means ये सर्किट ऐसा है कि इस ब्रांच में करंट होता है 0 amperes. It is fine. Even though we are doing the calculation, check the calculations once again when you will get the 0 values. But sometimes its answer may be 0. I have checked the calculation for this particular problem. Its answers are again 0. It is absolutely correct answer, I guess. Now here this I2 is 0. Now how is the value of the VTH? This VTH is equal to, it is a modulus of, we are traveling from the B towards A. We are traveling from the B towards A, negative to positive, that is a plus. Its voltage is 8. Then voltage across this is the Vx. How much is the value of the Vx? Which is 0. Fine. Otherwise, I can use the formula 4 into I2. That is also fine. 4 into I2, 4 is a constant, and how much is the I2? 0. Means indirectly, the voltage across this particular resistance will be 0. Then again, voltage across this resistance will be 0 because in this branch current is 0 because I3 is already 0 because it is open circuit. This plus which is 0 and this value is equal to 8 volt is the value of the VTH, which is nothing but VOC. I will come back to you. First we will check the calculation once again. If the calculations are correct, then these are the absolutely correct values. Yes, I will come back to you. Rishikesh.
Yes, sir.
Correct calculations correct है?
हाँ सर करेक्ट है.
हाँ रुचिरा. Saurabh.
Yes sir, correct है.
हाँ. So here in this case, if we know the value of the VTH, then we will find out the value of RTH. But what is the formula for the calculation of RTH? This RTH is equal to VTH or VOC, which is this itself, divided by ISC. This we have to find out this value, which is ISC. For the calculation of that value, what we will do, we will remove the load resistance and we will short the output terminals. That is the similar point. Now here, what I will write for the calculation of, just give me a minute. Yeah, I will start here. For the calculation of ISC, we will short output terminals by removing load resistance, by removing RL. How will be the figure? Now look at. In this case, its figure will be something like this. Its figure will be something like this. Yeah. There is A point, this is B point, this we are shorting. This we are shorting. Now, figure will be something like this. This is upward. This is 2 Vx. Here it is 5 ohm. This is 3 ohm. This is 4 ohm. This is plus and minus. This is Vx. Sorry, this is Vx. And this value will be the 8 volt. This is plus and minus. But I will treat this value as a Vx2 for this calculation. This will be the Vx2. क्योंकि पहले केस में हमने इसको Vx1 नाम दिया, तो Vx1 के साथ कंफ्यूज नहीं होना है. That's why this is the value. And here in this case, which method we have to use? I will come back to you and we will discuss first and then we will proceed further. Yes. Rishikesh.
Yes sir.
यहाँ पे कौन सा मेथड यूज कर सकते हैं for the calculation of current in the short circuit? Which method we can use?
सर नोड तो नहीं यूज कर सकते, शॉर्ट है.
गलत. गलत. शॉर्ट कब होगा? ये शॉर्ट यहाँ पे है, ये ब्रांच शॉर्ट नहीं है.
अच्छा अच्छा,
ध्यान में आ रहा है? यहाँ पे रेजिस्टेंस है, इसलिए नोड भी यूज कर सकते हैं और इसके लिए हम मेश भी यूज कर सकते हैं. बिकॉज इफ वी आर यूजिंग द मेश, दिस विल बी द सुपर मेश, right? And if we are using the nodal analysis, this is node 1, node 2 and node 3. Anyone has any doubt?
No.
Saurabh, are you getting the concepts?
Yes sir.
Because these concepts may be difficult to understand for the newcomer जो आज first time lecture में आए हैं, उनके लिए तो ये समझ में कुछ भी नहीं आएगा. But those students who are the regular, they may understand. Is it right? Now here in this case we can use both techniques. Both techniques. Now which will you use? I will take the call from Saurabh.
Yes sir.
कौन सा method use करना है?
Nodal analysis or super mesh?
Nodal analysis. Okay, fine. We will use the nodal analysis here. In this case, I will give some different name to this node, which is Q, and its potential will be the VQ. क्योंकि यहाँ पे already नाम है A, यहाँ पे already नाम है B, यहाँ पे already नाम है X. That's why I am using another node, which is VQ. So assume the currents. In this case, I will assume this current as, ये current का नाम देता हूँ मैं. This is I1 dash. Because second नाम से duplicate नहीं होना चाहिए. And while assuming the current to this branch, think about this polarity, plus minus. इसलिए इस branch का हमें direction लेना पड़ेगा ऐसे. Because it is suiting to this polarity, this current may be I2 dash. And current in this branch, I will give its name as ISC, that is short circuit current. In place of giving its third name as I3, I will give that particular name, and we will simplify this equation first. Otherwise, you can apply the super mesh to this this outer loop, and you can find out another equation from this current source branch. That is also the good approach. So here in this case, now I will write applying KCL at node Q. We are applying the KCL, that is Kirchhoff's current law, at the node Q. If we are applying the KCL at node Q, how is the KCL? This is incoming, this is incoming, this is outgoing. Means incoming currents is equal to outgoing currents. Means equation will be I1 dash plus this is I2 dash, which is equal to ISC. Is it right? अगर ये रेजिस्टेंस नहीं होता तो ये कंप्लीट शॉर्ट सर्किट होता और उस केस में हम नोडल एनालिसिस यूज नहीं कर सकते थे, बट ड्यू टू दिस प्रेजेंस ऑफ दिस रेजिस्टेंस वी कैन यूज द नोडल एनालिसिस आल्सो. This is I1 dash, current in this branch, which is 2 Vx2. This value is 2 into Vx2 is that current, I1 dash plus. I2 dash is the current in this branch, which is 8 minus Vq divided by 4. It is 8 minus Vq divided by 4 is I2 dash, which is equal to Isc. Isc is the current in this path. What is the equation? This potential minus this potential divided by the resistance, indirectly it is a Vq divided by 5 is the equation. Problem कितना भी complicated हो, try to follow your methodology. And while choosing the methodology, think twice, because whenever we have the dependent sources, there may be the little complexity. In that case, we can start in this way. So here it will be 2 Vx2 plus it is 8 divided by 4 minus it is Vq divided by 4, which is equal to Vq divided by 5. Is it right? What I will do? I will shift this Vx2 and Vq on that side, and I will take the Vq as a common. Then it is 1 by 5 plus it is 1 by 4, because if we are shifting this value to the next side, that will become plus, and this value will become minus. It is 2 Vx2, and the constant I am keeping on the same side, which is 8 divided by 4. It is 8 divided by 4. Is it right? It is 8 divided by 4. If we are simplifying this bracket, how much is the value of the Vq and this constant? I guess it is the 2. And this value is minus 2 Vx2. How much is the value of this bracket? Yes, anyone? I'm expecting the answer from your side. Yes.
0.45 Vq.
0.45 Vq is this term. Already we have given the names to the equations, I guess 2, and this will be the equation number 3. This is the equation number 3. If we have this equation, now look at, we have the two unknowns, right? One unknown is Vx2 and another is Vq. This we will find out Vq in terms of Vx2, because that is the choice with us. Is it right? I will write the same. Now we will find, or we will calculate Vq in terms of what? Vx2. Is it right? Now how is the Vq? We are interested in this potential. We can use this path. We can use this path. We cannot use this path. लेकिन ये path use करेंगे तो Vx2 में relation नहीं मिलेगा. That's why again we have to follow this path, because we are interested in finding the relation between Vq and Vx2. So here, if we are finding the Vq, which is equal to this potential is with respect to what? This potential, which is ground. Because in the nodal analysis, we will treat it as one node and this is ground node with respect to this ground node. If we are traveling something like this, negative to positive, which is plus 8, then positive to negative, which is minus, this is Vx2. Vx2. So how will be the equation? Equation will be Vq plus Vx2, which is equal to 8. This is the equation number 4. This is right. This is the equation number 4. Now we have the equation number 3 and equation number 4, two equations and two unknowns. Find out the value of the Vq and Vx first, or Vx2 to be exact. By knowing these values, what we are interested in the Isc. What is the formula for Isc? Vq divided by 5. Means only this value will be sufficient. And we can use that formula, which is Isc, which is equal to, it is Vq divided by 6. How much is the value of the Vq? Yes. Anyone has the answer? Should I go for the calculation? This is equation. We have the two unknowns. Yes, I will start. Yes, anyone has answer?
Sir,
Yeah,
VQ is equal to 7.34.
7.34 volt. Yes, Shailesh.
0.65 volt.
This is 0.65 volt, right? Yeah, I will check the answer with someone. Shailesh,
Correct.
correct?
Yes.
Okay, fine. I will check another someone. Yes, Saurabh.
Yes, sir, correct.
Okay, fine. If we know this ISC, now VQ divided by 6 is the equation. VQ is 7.34 divided by 6, which is equal to, this is 7.34 divided by 6, which is equal to 1.22 amperes. This is 1.22 amperes is the value of the ISC. Now we will find out the RTH. Now RTH is equal to VOC divided by ISC, which is same as VTH divided by ISC, which is equal to, how much is the value of the VTH which we have calculated in the last step? The value of the VTH which we have calculated in the last step is the 8 volt. Is it right? This value will be 8 divided by 1.22. Find out this value. It is 8 divided by 1.22. If we are finding this value, it is 6.557 ohm. 6.57 ohm. 6.55. 6.55 ohm is the value of the RTH. Right? I will check the answers with someone. Yes, anyone has the answer? Please unmute yourself and tell me the answer. Yeah.
Correct,
Rishikesh.
sir.
Correct. So here in this case, if we know the RTH, then complicated network will be replaced by the Thevenin's equivalent network, and this will be the Thevenin's equivalent network. This is the Thevenin's equivalent network. This value is 6.55 ohm is the value of the RTH, and the value of the VTH which we have calculated in this particular case is 8 volt, I guess. This is 8 volt. And reconnect the load resistance which is removed in the first step. Load resistance is RL, and we are interested in the calculation of this RL. Therefore, as per maximum power transfer theorem, what we have? We have this RL is equal to RTH, which is equal to 6.55 ohm is the RL. Yes, we have completed the first part of this question, which is calculate RL. Now, if we know the RL, we will find out its IL. This IL is equal to current, in this case, IL, this current. What is the formula for the current? In this case, the formula for the current is total voltage divided by total resistance. Total voltage is 8, total resistance is 6.55 plus 6.55. Find out this value and tell me the IL, that is load current. Yes, anyone?
0.61.
0.6.
0.61 amperes, correct?
Yes, sir.
Okay. If we know its IL, that is load current, we will find out its maximum power, that is Pmax. This is maximum power, which is Pmax is equal to, this is IL square into RL, which is, this is 0.61, its whole square into RL, which is 6.55. Find out the maximum power which is transferred to the load in this case. Unmute yourself. Yeah.
2.43.
2.43. This is 2.43 watt is its value. I will check with someone. Who has answer? Rishikesh.
Correct, sir.
Okay, fine. Okay, fine.